Hello, welcome to Chapter 1, Section 5. Now, last time we solved absolute value equations. Today, we're going to solve absolute value inequalities. And we've been dealing with inequalities because when we did domain and range, we had to know notation, right, and what everything meant. If there's a line under it, it's closed. If there's not, it's open. And that's still going to apply today. Now, the concept for solving an inequality is pretty much the same as solving an equation. There's just a few extra steps. So let's make sure we know some basic things about inequalities first. Reminder, when multiplying or dividing by a negative number in an inequality, okay, anytime you multiply or divide by a negative number, you have to flip the inequality. Okay, that inequality is going to flip, and I'll show you many, many examples of this happening. Now, to solve absolute value inequalities, if it's less than, okay, so to solve if it's less than, you solve the compound inequality where there's the positive and the negative, but because it's less than, we're going to write less than, well, we're going to say that this is and, okay, that's how I want you to remember it, less than. So the sign in between is going to be and. And there is a difference because if you have a greater than, you have this, and greater, so greater, and we're going to put an or, okay? So if it's less than, it's and. If it's greater, then it is or. Okay, and I'm going to show you many, many examples, so bear with me right now. I'm going to do 4 examples, all right? So now the first thing we need to do first is make sure it's isolated. Is that absolute value by itself? Well, in this case, yes, it is by itself on the left-hand side of the inequality. Then you have to use reason. Okay, step 2, use reason. Does this make sense? Okay, can I have a distance that is less than or equal to 2? Yes, so I'm going to proceed. Okay, there will be times when it doesn't make sense or when it's obvious that this always happens. So you're never going to have to deal with it, okay? But in this case, yes, x plus 3 can be less than 2, so we're going to keep going. And we'll go over this more and more and more. It'll be okay. If you don't understand it now, make sure you ask questions when you get to class. Write your questions down. So we're going to have the positive version and the negative version, and we're going to solve. So minus 3, and because it's less than, there should be an and in between. Okay, less than, and. So we have x is less than or equal to negative 1. Distribute the negative, so we have negative x minus 3 less than or equal to 2. Add 3 to both sides. Negative x less than or equal to 5. Divide by negative 1. Well, I divided by a negative, which means that this has to flip. So when I draw my picture, it's less than or equal to negative 1 and greater than or equal to negative 5. So I'm going to have my negative 1 and my negative 5. Now it's or equal to, so they're both closed. And it's less than negative 1, greater than negative 5. So we are everything in between because that was an and. Okay, so this is your answer. All right, now let's look at this. Solve. The absolute value of 3c minus 5 is less than negative 2. Now, is it isolated? Yes, good. Moving on. Reasoning. Reasoning. You have to reason about what is going on here. This is saying that a distance is going to be a negative number. Is that possible? No, it is not possible because all of our absolute values end up being a positive number, right? They have to be positive. So you're never going to get a negative number, so this automatically, no solution. No solution. It's not possible. It is not possible because you cannot have a negative absolute value. Okay? So, we can move on. Oh, next page. Solve this. Okay, Well, let's try that. First, is the absolute value isolated? Yes, it is. In this case, it definitely is. And can you have an absolute value greater than or equal to 3? Of course. Of course. So we are going to continue in our process, our normal process. We have the positive version and the negative version. And because it's greater, it should be an or. So we're going to solve. We're going to subtract 1 from both sides. And we're going to get x is greater than or equal to 2. Then we're going to distribute that negative. And we're going to have negative x minus 1 is greater than or equal to 3. Add 1. So negative x is actually greater than or equal to 4. But we can't have a negative, so we divide by negative 1. So x, we have to flip the inequality. So x is less than negative 4. Negative 4. So x is greater than 2 and less than negative 4. Or less than negative 4. So we're going to come over here, put our negative 4 and our 2. They're both closed because it's or equal to. And then it's less than negative 4, so we're going this way. It's greater than 2, so we're going that way. Okay, so we have the or, and that is our answer. Last one. First, this is your first example of something where the absolute value is not isolated, because what is in front of our absolute value? A negative 4. Now, in order to get rid of that negative 4, you see that it's multiplied to the absolute value. The only way to get rid of it is to divide by a negative 4. Well, if you look at what I just did, right, those cancel. We end up with 6b minus 8 in the absolute value, but I divided by a negative. And as soon as I divide by a negative, it's got to look like that. And that's going to be negative 3. Now you have to use your reasoning, right? Because I'm isolated, and that's okay. Is there going to be a time when, is it possible to have an absolute value greater than or equal to negative 3? Well, the honest answer is yes. In fact, because we can only have a positive absolute value, it is always going to be greater than or equal to negative 3. So you don't even have to do the math. Okay, you don't have to do any math. Because it's always greater than or equal to negative 3, this will always be true. So this will be true for any value of b. Sorry. So the answer is all real numbers. Okay? And you can graph that. It's simply the entire number line. Okay? So if it's ever always going to be true, then you have all real numbers. If it, like in example 2, is never going to be true because you can never have a negative absolute value, then it's no solution. If it's neither of the two, you've got to work it out and then graph it. Okay, those are your options. So, greater, and it's or, less than, and it's and. Have a wonderful day.